Hi everyone, Aaron here. Determining accurately the direction that a phase reaction is proceeding in a phase reaction experiment is the single most important piece of data that experiment can provide. And yet, it is often somewhat frustrating because it is difficult to determine exactly how the authors got the values that they got. This video is different than the ones that I've shown in the past. Rather than giving you a polished video explaining exactly how to do something, I'm going to do a side-by-side tutorial as I fill out the reaction columns in a particular data set so that you can see what my workflow looks like. And for that reason, that's why I have work music on. So we're going to be focusing on the Richardson 1969 paper. You can see here. It is concerned with reactions between kyanite and andalusite and sillimanite. And before this video, I've already filled out every single tab in the phase reaction file. And in fact, all of the columns in the reaction tab, except for the results and the reaction direction certainty. Now, before we start filling those out, I just want to go over how I filled out the columns having to do with the method and the reaction metric, because that's going to play a very important role. So to do that, you take a look at the data tables, and you can see that in this paper, they used X-ray diffraction peak ratios between kyanite and andalusite, and in table 4, between andalusite and sillimanite, to determine which direction the reaction was proceeding. And so for that reason, I've said that we have XRD peak ratio for all of them. The units is ratio. It's a unitless quantity. And then we need to store what the initial and final values for that reaction metric are, this peak ratio. The final values are very easy. Those are just the ones stored in the column, the appropriate column of the table. And so I've copied those down into this reaction metric final column. For the initial values, there we have to take a look, and if you scroll to figure 1, oftentimes this is provided either in a figure or maybe in the text somewhere or maybe in the comments to the table. They give you the sense of what are the range of initial values before the reaction was allowed to proceed. And so you can see from these two, you can determine that the initial XRD peak ratio, or reaction metric, was between 0.8 and 1.08 for the kyanite andalusite runs, and between 0.53 and 0.7 for the andalusite sillimanite runs. Finally, we need to store information about the reaction metric error. Honestly, this is a little bit confusing, but once you understand it, it's not a problem. So the reaction metric error indicates how much did the reaction metric itself need to change from its initial value to its final value in order to identify that as a proceeding of the reaction in one particular direction or another. So in many of these papers, they will say that they will quote a threshold, and it's usually stored somewhere in the text. Here you can say that they say a threshold, a conversion of 20% of one polymorph to the other of the starting material is what they considered a clear indication that the reaction is going in one direction versus another. And so 20% of one polymorph to another would correspond to a 40% change in the ratio of one polymorph to another, because the numerator goes up by 20%, denominator goes down by 20%. The overall change is 40%. Now, that is for a clear change. So we would consider that something like a 2 sigma or 95% confidence change away from the initial value. And so we want to actually store half of that value. So a 20% change in the reaction metric would give you, if you change by more than 20%, then you're pretty clear that you've at least not stayed the same value. So anything anything less than a 20% change would just be a no real change observed. It's basically equal to its initial value. Anything between a 20 and 40% change is a questionable or maybe probable change, and anything greater than a 40% change is a clear change. And so we'll see that as we fill out the results column. So now let's go to the kyanite andalusite table. And we have all of these things stored, and they actually provide us results. So the first thing we're going to do is we're just going to fill out the clear results wherever they indicated them. So it looks like in 9 and 10, and again, remember, we have to give the official abbreviation, a space, and then what occurred. So kyanite increased here and here for runs 9 and 10. Also jumping down here, andalusite increased in 15, 16, and 17. So let's fill that out. Andalusite increased clearly in these. And for yourself, if you like to emphasize it, we also provide a reaction direction certainty. So if you like, you can put definite on those, because they were even reporting this. I'm just going to copy and paste that. Now, to be fair, it's not absolutely required that you put definite, because we've used a plus sign here and not a plus question mark. So plus already indicates that unless we indicate otherwise here, that it's a clear reaction. But you can do that if you like. Then we have a questionable andalusite reaction for run 19. Andalusite plus question mark. And then in reactions 24 and 25, hope you guys like Radiohead. Reactions 24 and 25, we've got a clear andalusite change, and reaction 28 is a clear kyanite change. And 34 is andalusite, and 36 is kyanite. Okay, so that's it for the ones reported by the author. Now, you might be tempted to just leave these blank, or maybe say that there was no change for all these blanks and then move on. But that is not what you should do. There is more information in this paper, and we want to extract all the information. So first, the next thing we do is we look at the comments. And so it looks like quartz and corundum appear in some of these. Sillimanite appears in some of these, so we need to store that information. So under the results, for the first one, apparently corundum increased, even though it wasn't present initially, and quartz also increased. And apparently those are the only things that were there. So that must mean that kyanite decreased and andalusite decreased. So that's the result for that first run there. Second run has some sillimanite. So we can say sillimanite increased. And there's a little bit of corundum, so maybe we give that a question mark. And is there anything else? Sillimanite plus quartz, trace glass, no corundum. So in 37, we had sillimanite plus quartz plus, and it's not quite clear what else happened. Some sillimanite, no glass or corundum. So in the final one, 40, we can say also some sillimanite. There we go. So that's it now for the comments. And now we turn to the reaction metrics. So here we can essentially recognize that anything that the authors themselves did not indicate as a clear reaction, we probably should not put as a clear reaction ourselves. So we're going to use the question mark, just like here, the question mark or probable reaction direction for the rest of them. And so there are two ways to do that. We can do that either using the plus question mark or using the probable indication here. And then all the rest of them we're going to indicate as unresolved. All right, so let's take a look. This one started off 0.8 to 1.08, so if we are outside that range, then we have a questionable reaction. So since that is a small value, and this is the kyanite to andalusite range, that means that kyanite decreased questionably here. And likewise, kyanite decreased questionably there and there. Any value that is below 0.8 is going to be a questionable decrease. This one is not below 0.8, it's equal to 0.8. So here, we're going to say that kyanite remained the same. Now notice, I could be typing these in terms of andalusite. It does not matter. I can choose whichever one. I'm just choosing kyanite because it's the numerator, and so it's easier to think about. So again, everything less than 0.8 is going to be a questionable reaction. Anything more than 1.08 will be a questionable increase. This one is less than 0.08, so kyanite remains the same. This is a decrease. This is a decrease. This one this one stayed the same. And make sure you actually typed the actual values. And we're almost done here. This one decreased questionably. This one stayed the same. Decreased questionably. And here's where we need to, you should have a little puzzling thing here. Like maybe we didn't fill this out quite right because this one is a questionable, but it's 0.65, which is quite clearly less. And also this one, which is 0.65, has a clear kyanite decrease or andalusite increase. So let's take a look and see, did we actually fill out the table right? And here's where you realize, andalusite increased, but it wasn't just 34, it was 33, 34, and 35, applying to all of those. So let's fix that now. 33, 34, and 35. Are there any other cases where we made the same mistake? None of these above are like that. It looks like, no, that was the only one. Okay, good. We caught an error. And then we've got, okay, so that's the end of the kyanite and andalusite ones here. Now, if you wish, we also could have indicated those, if you prefer, instead by saying, for instance, if I didn't want to say kyanite equals, we could have said unresolved here. And that would also be a fine way to indicate this. And for this, if you prefer, you could have said minus, and then it's only a probable reaction. Either one of those is okay. And there are some cases where it's easier to use the reaction direction certainty, and other cases where it's easier to use these text indicators. Personally, I prefer the text indicators, but you can choose whichever you prefer as long as you are consistent. And it looks like that's basically everything that we needed to do. The last thing to check is, are there any issues with biased results, where the result of the reaction, it just doesn't even seem to relate to the reaction we're studying? And in fact, there are. Here we had ones where corundum increased, quartz increased, kyanite and andalusite both decreased. This is clearly not the reaction that we are supposed to be studying. So in this case, we want to indicate it with a biased indicator. And likewise, this one had sillimanite increase, even though we're trying to study the kyanite-andalusite join. And so that one we can also indicate with a bias result. Are there any others that were selenite plus quartz, trace glass, no corundum? This one apparently doesn't even have any kyanite or andalusite. It's 37. Excuse me, 37 right here. Selenite plus quartz, kyanite decreased, andalusite decreased. This thing is clearly not actually showing the reaction reasonably. And then it's the, oh, and you can also see that because it had no measurable peak ratio. And so that is something that we also should see, that there was a missing ratio here. And so it's not even commenting on this reaction at all. And then this one is fine. So that's it. We have now completed the results for the kyanite andalusite experimental runs in Richardson 1969. And hopefully you have found this useful. You can see how in just a few minutes you can go through and clearly determine what the authors observed, and in many cases even extract more data than the authors themselves presented in terms of the interpreted result. Thanks, and see you next time.